Hi, so welcome back to the next lecture. Today I'll be talking about implicit differentiation and related rates. So to give an introduction, what I'll do is I will um, I'll take one example to start with. Suppose this is my function 4x to the third plus 2y squared plus 9, and then the question is, can you find the y prime or can you find dy over dx? So this equation can be thought of as y is same as square root of 4. Oh, sorry. So I can write this as 2y squared to be 9 minus 4x to the third, and then y squared can be written as 9 minus 4x to the third over 2. So y becomes square root of 9 minus 4x to the third over 2, right? So now I have my variable y written in terms of x, and then I can use the differentiation laws to find the y prime, right? And now what if my equation is given like this, where you have um, the variable y two times appearing in the equation, then how can you find y prime or dy over dx? So this sort of question can be answered by using the methods that will be um, observing in this section. So um, and then if you have fx given as this, then how to find f prime x? This should not be difficult because f prime x can be written as 2 times. So um, so if I consider derivative of this, I should get 2 times 4x to the third plus 2x times 12x squared plus 2. This is derivative of outside function, and this is derivative of inside function, right? This is basically using the chain rule. So, so what I want to say is you have to use chain rule several times in this upcoming problems. And so we'll see if I have an equation like this. This is called an implicit equation where, so this is called explicit form, right? Because why? Because I know y given in terms of x, but this is called implicit form because you have y and x mixed randomly in your equation. Okay, cool. Maybe I just mm, arrange this a little bit. Okay, now let me start with implicit differentiation. Example one is assume that y is a function of x, and then you have to find ddx of y to the 5. Okay, so see that this is a different variable y, and I'm doing derivative with respect to x. So I can think about this as I can use power rule to say this is my derivative, but then I don't have x to the 5, I have y to the 5. So for that reason, I should have this dy over dx, right? You can think this again in terms of chain rule. So similarly, If I want to do the next problem, this is like f times g. So I'll get f prime times g plus g prime times f. So f prime would be just 2x, and then g is just y to the third. That is fine. And then g prime. So now again, for g prime, I know that my g is y to the third, right? So using power rule, I get 3y square, but then I got y, and I'm doing differentiation with respect to x. That's why I should have dy over dx, right? And then I have f, which is just x squared, okay? So you can think about this as derivative of inside function, right? Okay. Now, if I have a very simple implicit form, then can I find dy over dx? So for that, I had this equation, and then if I do take derivative with respect to x, then I get 2x plus 2y times dy over dx by the same logic, same reasoning. And then on the right hand side, if I do d dx of 100, I should get back 0 because derivative of constant is 0. So I get 2x plus 2y dy over dx, right? My goal is to find dy over dx. So I want dy over dx in one side. So I can subtract 2x to get negative 2x on the other hand side. And then I can divide by 2y to get dy over dx on the left hand side. So ultimately, I get minus x over y as my dy over dx, right? Okay. Now, to formulate how we should try to find implicit differentiation, I'll write 2 steps for that. So step 1 should be differentiating both sides of the equation with respect to x. And when you differentiate y, the y term, then multiply by dy over dx. That is, what do I mean by that? I mean that when you have y square, you use the power rule to get 2y and then multiply by dy over dx. Okay. Okay, and the step 2 is next you have to solve for dy over dx. That means you separate out dy over dx on one side and you do the arithmetic to simplify the dy dx as much as you can. Okay, the next example is again is of similar type. So step 1 is to take derivative with respect to x on both side of the equation. So I get 3x squared, that's fine. And then I get 4y to the third using the power rule for y to the 4. And as I have y to the 4, and I'm doing derivative with respect to x, so therefore I should multiply by dy over dx and 0 on the other hand side. And then I am doing the arithmetic to separate out dy dx on one side. So I subtract by 3x squared to get this, and then I divide by 4y to the third to have dy dx and dy dx alone on the left hand side. So I get this as my final answer. Okay, cool. The next example is I have an equation which is x squared plus y squared to be 100. If you recall, this is equation of a circle of radius 10 and center at origin. You have to find the slope at the point 5 comma 2. So if you recall, that slope is just dy over dx, right? So basically, you are being asked to to find dy dx at the point 5 2. So we know how to find dy over dx. We just take the derivative with respect to x, both hand side. Then we get 2x plus 2y dy over dx, right? By doing the derivative, and then 0 on the other hand side. And then we just subtract 2x to get 2y dy over dx to be negative 2x. And then we just divide by 2y to get minus x over y as my dy over dx. Now I need the slope at 5 comma 3, right? No, 5 comma 2. So I just choose my x to be 5 and y to be 2 to get my slope to be negative 5 over 2. So this is the slope of the circle. Rather, this is the slope of the tangent um, of the circle at the point 5 2. Okay, so this is more or less the basic stuffs that you need to know for the implicit derivative. The next section is about related rates. So for that, there are some steps that you need to follow. So step 1 is you have to draw a picture if needed. The next step is to figure out what rate do you know, which rates are given to you, and then what rate you are looking after. Okay. Next step is to find the relationships between the variables and then you differentiate the equation of the relationship. So differentiate the equation of the relationship, and then at the end you plug in values. Okay. So let me do an exercise to better explain that. So suppose you have an expandable sphere which is being filled with liquid at a constant rate from a tap. Then when the radius of the sphere is 3 inches, the radius is increasing at 2 inches per minute. Then the question is, how fast is the liquid coming out from the tap? Okay. And you are also given with the the formula of volume of a sphere as 4 over 3 pi r to the 3. So this time I have the equation or the relationships. So the step 4 is already being uh, done. Oh, no, sorry, it's not step 4. Step 3 is already given to us. So, and also I don't need to draw a picture, but, or maybe I can draw the picture very vaguely. So say this is my sphere of, say, radius r, and the water is being or the liquid is being filled into the sphere. Okay, so now the next step, or so step 1 is done. Step 2 is to figure out what rates do I know and what rates do I have to figure out. So I know that, so step 2, maybe you can write step 1. I know that the radius is increasing at 2 inches per minute, right? So radius is increasing. That means dr over dt, because t here represents this time, right? So you know that radius is increasing 2 inches per minute. So therefore, I should write dr over dt to be positive 2 inches per minute, right? If the radius was decreasing, then I had to consider negative 2. So for increasing, I have positive sign. For decreasing, I should consider the negative sign. Okay. Now, what do I want? What rate do I want to evaluate? So I want to evaluate the dv over dt, right? And at when radius is 3 inches. Okay. Now the relationship that I am given with is v to be 4/3 pi r to the 3. So step 2 is done. Step 3 is done. Now step 4 is to differentiate the relationship. So as I am interested in dv over dt, so therefore I should consider ddt, both side of the relationship. So I get dv over dt to be 4/3 pi 3r square, and then dr over dt, right? Because I have r and I'm derivating with respect to t, so therefore, as r and t are different, so therefore I should consider the extra factor dr over dt. This is almost the same as when you multiply dy over dt that I was talking about previously. So the reasoning is the same here as well. And now this 3 and that 3 cancels out and gives you 4 pi dr over r square dr over dt. I know that I need to evaluate dv over dt at when r is 3. So I can put r to be 3 in my equation. So 3 square. And I know that dr over dt is 2 inches per minute. So I get 2 for dr over dt. So I get ultimately 72 pi, and then it should be inches to the 3 over minute as my unit, right? Because I know that the unit for v is inches to the 3, right? Because I have r to the 3, that's why I have inches to the 3 in the unit of volume. And I'm doing for dv over dt, I'm doing with respect to t. So as I have only d over dt, so I get inches to the 3rd over minute as my unit. Okay. For the next exercise, I have a triangle where the sides are given as x, y, and z. And at the instant My x is of 15 unit, y is of 13 unit, and then my dx over dt is given as um, 3, and dy over dt is given as -3. So this x is increasing 3 unit per time, and y is decreasing by -3 unit. So y is decreasing by 3 unit um, per time. Okay, now I have three questions. Is the area of the triangle is increasing or decreasing? And then the hypotenuse is increasing or decreasing, and the perimeter is increasing or decreasing. So this would be a little bit lengthy problem, but let me start doing it. Let's see where it goes. So I know that dx over dt is 3 and dy over dt is -3. Now for A, I need to figure out that the area is increasing or decreasing, right? So that means I need to figure out dA over dt is bigger than 0 or dA over dt is less than 0, right? That is how we figure out some quantity is increasing or decreasing, right? Okay. Now, what is the relationship that I um, need to study? So I know that the area of a right angled triangle is half times the base times the height. So this is the formula. And now I can take the derivative with respect to t. So I get, so this is like the product rule, right? So this is f times g. So I get half um, as a constant outside. And then I'll write 1 times dy over dt. This is my f prime time, oh, sorry, f prime times g. So just that. And then, oh, okay, no, wrong. So I need to figure out dA over dt, right? So half d dt of x times y. Okay, so I have half outside, and then for x, I'll get 1 times dx over dt. This is f prime. This is g, times y. This is my g, plus now I have x as my f times 1 times dy over dt as my g prime. Okay. Here x and y both are two different variables, and t is the independent variable. So as you are doing derivative with respect to t, that's why you have dx over dt and dy over dt extra multiplier when you take the derivative of f prime and g prime in the product formula. Okay, so if I try to write it down, I get 1 times 3 times 13, because 3 is the value of dx over dt and y is given as 13, right, in the picture. Okay, and plus I have x, which is again 15 times -3, because -3 is the value of dy over dt. So I get half times 39 minus 45, which is like -6 over 2, -3, which is less than 0. So therefore, the area is decreasing. Okay, cool. The next problem is to figure out that my hypotenuse is increasing or decreasing. So I need to figure out z. So for z, my relationship um, that I need to focus on is the formula of Pythagoras theorem, which is z square is x square plus y square for right angle triangle. So if I do the derivative, I get 2z dz over dt to be 2x dx over dt plus 2y dy over dt. So by now we should be familiar to deal with this. And then I divide by 2z to get 2x dx over dt. I can factor out 2, right? Um, over 2z. The 2 gets cancelled. So I get my um, mm, okay, cool. And also from this, I can write z to be square root of x squared plus y squared. So I would just replace z by x squared plus y squared there because I don't know what is the value of z right away. So I just replace the x square, square root of x squared plus y squared in place of z. So I get this very bad looking expression. And rather, let me just maybe I just add one page to this. Okay, so now if I put down all the values in, I should get 15 as my value of x and 3 as my value of dx dt plus 13 as my value of y, negative 3 as my value of y dy over dt, and then square root of 15 square plus 13 square. So if I calculate it, I should get 45 minus 39 over square root of 394, which is 6 over square root of 394, which is positive. So I know that my hypotenuse is also increasing. Okay. For part C, I need to figure out the perimeter is increasing or decreasing. So my perimeter P is x plus y plus z, right? So I know that this is nothing but x plus y plus square root of x squared plus y squared, which is just x plus y plus x squared plus y squared to the half. Okay. So I can take the derivative. So I get dp over dt to be dx over dt plus dy over dt plus half x squared plus y squared to the negative half, and then using chain rule I get 2x dx dt plus 2y dy dt. Okay. um okay, maybe I just uh, do the derivative of x squared plus y squared to the half and show you how I get that. So again, I have to use a chain rule. So this is my outside function. So I get half x squared plus y squared to the negative half. This is derivative of outside. And then for derivative of inside, I get 2x dx dt plus 2y dy dt. This is my derivative of inside. And then I just replace the whole thing right there. Okay, cool. Um, okay, and then the rest is dp over dt. I just replace down all the values that I know. So dx over dt is 3. So from there, plus negative 3 is the value for dy dt, then half of 3 square plus negative 3 square, right, to the negative half times 2 times 13, I guess, is the value of x, right? No, 15 is the value of x. So 15 times 3 plus 2 times 13 times negative 3. So this is just 0. I get half, then 18 to the negative half. So let me write as it is, and then mm, 90 minus, so you get 13 times 6. So you get negative 78, I believe. Okay, which is again positive. So your perimeter is also increasing. Okay. Okay. I have one more problem, but I'll just sketch the problem here. So you got the equation as this big quantity um, given to you. So what you have to do is, the first step is um, you just take the derivative um, with respect to x, because here what you have to do is you have to figure out the tangent line. So tangent line at the point 1 comma 1, so for that you have to figure out the slope of the tangent at that point. And for slope I need to know dy over dx, right? So that means I just have to take the derivative with respect to x to the equation. So I get the equation like this, and then you just use the power rule several times. So minus 54 times 5 x to the 4 plus 36 times, so 8 times 36 times x to the 35 y plus, so again you have to use the product rule, plus 8 times x to the 36 times y dy over dx plus 10 y to the 9 dy over dx to be equal to 0. Okay. Again, if you simplify further, you get this as your simplified form. So this term is without any dy dx, and then the other two terms has dy dx. You can factor those out. Okay, and then you simplify the expression and separate out dy dx. So you subtract this whole term and take it to the other side. So you get 270 x to the 4 minus 288 x to the 35y. So you get dy over dx to be 270 x to the 4 minus 288 x to the 35 over 8 x to the 36 plus 10 x to the 9, and then you get the slope at 1 1. Just choose the value 1 comma 1 for x comma y in your expression for dy dx. So you get 270 minus 288 over 8 plus 10, which is minus 18 over 18, which is just negative 1. Now, ultimately, the equation of the tangent line. So to figure out the tangent line, you need two informations. One is slope, which is negative 1, and one point, which is 1, 1 in this case. So you get y minus y naught to be m times x minus x naught. I know that my x naught is 1 and y naught is also 1. So, and m is negative 1. So if I just input all those information in, I get y to be negative x plus 1, y minus 1 to be this, and then y is just minus x plus 2. So this is the equation of the tangent that you need. Okay, so this is more or less about the section, and And yes, I'll stop here. If you have any questions, you can meet me after the class on Wednesday and ask me questions. Okay, see you.